If you have been online lately, you have probably seen it. People yelling 67, flashing the gesture, and acting like the number 67 is some kind of cosmic password. The meme is mostly nonsense, but the number itself is not. So let us do what the comments section will not. Take 67 seriously for a few minutes. Start with the basics. 67 is prime. You cannot break it into smaller whole number factors. It is the 19th prime in order, one of the atoms of arithmetic. Primes are the building blocks of multiplication, which is why they show up everywhere from cryptography to pure number theory. Even the plain look of 67 hints at structure. In binary, 67 is written as 10000011. That is 64 plus 3, a clean power of 2, plus a tiny nudge. It sits right next to something perfectly regular, then refuses to factor anyway. Now the first real twist. 67 is a prime of the form 4 times n plus 3. That matters because of Fermat's theorem on sums of two squares. An odd prime can be written as a squared plus b squared, only when it is of the form 4 times n plus 1. For example, 5 equals 1 squared plus 2 squared, and 13 equals 2 squared plus 3 squared. But 67 is 4 times n plus 3, so it cannot be a sum of two squares. Not unlikely, impossible. 67 also sits in a cute prime spacing pattern. Primes that differ by 6 are nicknamed sexy primes. 61 and 67 are one pair, and 67 and 73 are another. So 61, 67, 73 form a little chain with equal spacing. Primes are famously irregular, so whenever they line up like that, mathematicians notice. A quick complex numbers bonus. 67 is congruent to 3 modulo 4. Primes like that stay prime even in the Gaussian integers, numbers of the form a plus b times I, where I squared equals -1. Some primes split into a plus b times I times a minus b times I. 67 refuses. It stays stubbornly prime in more than one universe. Now for the part that makes 67 genuinely weird. It is a Heegner number. There are only 9. 1, 2, 3, 7, 11, 19, 43, 67, and 163. These numbers come from imaginary quadratic integers, where you allow the square root of -d into your number system. In ordinary integers, we depend on unique factorization. Every number has one prime recipe, but in many extended systems, that breaks. In the system, the integers adjoin the square root of -5. You can write 6 as 2 times 3, but also as open parenthesis 1 plus the square root of -5 close parentheses times open parenthesis 1 minus the square root of -5 close parentheses. Same number, two different prime-like factorizations. That kind of failure is exactly why factorization in these systems can get messy. Heegner numbers are the rare cases where order comes back. When D is a Heegner number, the system has class number 1, meaning factorization behaves nicely again. The fact that there are exactly 9 such D values was a deep story connected to Gauss, and later proved using tools like modular forms and elliptic curves. In other words, 67 is not just a random prime. It is sitting on a very short, very exclusive list. And that deep symmetry produces one of the closest things math has to near magic, exponentials that land insanely close to integers. Take e to the power of pi times the square root of 67. It is approximately 147,197,952,743.9999998,662. That is off from the nearest integer by about 1/millionth, which is ridiculous for something built from e pi and a square root. Even stranger, it is extremely close to 5,280 to the third power, plus 744, which equals 147,197,952,744. And yes, 5,280 is the number of feet in a mile, so it is literally a mile cube plus 744. The 744 is famous because it appears in the modular J invariant, the, quote, J invariant, a modular function that shows up all over this topic. The most famous version of this trick uses d equals 163, where e to the power of pi times the square root of 163 is even closer to an integer. 67 is basically the smaller cousin of that phenomenon. Quick bonus facts to end on. 67 in ASCII is the capital letter C. Element 67 on the periodic table is holmium. In astronomy, Messier 67 is a famously old open star cluster. And if you play the happy number game where you repeatedly replace a number by the sum of the squares of its digits, 67 falls into the classic loop that ends at 89, so it is not a happy number. So next time the internet treats 67 like a secret code, you can smile. The meme is silly, But 67 really is a rare prime, with deep connections to factorization, modular symmetry, and one of the strangest near-integer coincidences in math. If you enjoyed numbers with hidden personalities, subscribe for more.